Hey everyone, welcome back for another deep dive.
Ah,
Today we are going to be tackling something that sounds kind of complex but is actually super interesting, I promise. Ontology.
yeah, ontology.
It's all about how we organize and structure knowledge, and even cooler, how we can teach machines to do the same.
Right.
And we've got this really insightful document here that dives into the nitty-gritty of ontology and especially its impact on AI.
Especially these large language models that are making so many headlines lately.
Exactly.
Yeah.
So by the end of this, you'll be able to just casually drop ontology
Yeah,
in conversation and sound like a total AI expert.
definitely. We'll make sure to break it down in a way that makes sense, even if you're not like a tech wizard or anything.
Perfect.
Yeah.
So let's start with the basics. What exactly is ontology?
Well, you know how like a company has an organization chart?
Yeah.
Our source uses that as an analogy, and I think it works really well for understanding this. So ontology is kind of like that. It's all about defining the things that exist in a specific area, like a company, and then figuring out the relationships between all those things.
Okay, so in that company chart example, you have the employees like Alice, Bob, Charlie.
Right. Those are your entities in ontology speak.
Got it. Entities. And each person has those attributes, like their name and their role in the company.
Exactly. And then you have departments like engineering or marketing, which are also entities, and you see the relationships between them, like who manages whom, who works where.
It's like this whole web of connections and information.
Yeah. And an ontology basically maps out all those connections in a really clear way.
It's like creating a blueprint for how knowledge works in a particular area.
Yeah, like a blueprint. I like that. And that's where it gets super relevant for AI, because think about it. You want an AI to understand how a company operates.
You give it the ontology.
Exactly. It's like giving it the company's manual so it knows all the key players, what they do, and how they interact.
So it's not just throwing a bunch of data at the AI. It's giving it that framework to actually understand and use that data.
Right. Makes a huge difference.
It makes total sense. No, it's really fascinating to me is that the way we represent these ontologies has actually evolved a lot over time.
It really has. Almost like a language evolution, but for machines instead of humans.
Exactly. It's like we went from, hieroglyphics to emojis or something.
That's a good way to put it. But yeah, in this case, we're talking about moving from generic languages to these markup languages for representing ontologies.
And each language has its own little quirks and advantages.
Definitely. And it just highlights how much work has gone into figuring out the best way to represent this complex knowledge so machines can actually understand and use it.
Right. So let's unpack some of these languages. Our source mentions a bunch, but are there any that really stand out like the superstars of ontology representation?
Oh, absolutely. There are a couple that really changed the game.
Yeah.
Yeah, for sure. OWL and RDF, RDFS, those have become especially important with the rise of LLMs.
Okay. Those names do ring a bell. I remember them from sort of like the semantic web and linked data stuff, but why are they such a good fit for LLM specifically? What's the secret ingredient there?
Well, you got to think about how LLMs work. They're amazing at processing tons of text and finding patterns, but they don't always get the deeper meaning like we humans do.
Yeah, it's like they can read a whole dictionary, but then you ask them to tell you a story. And
Exactly. And that's where OWL and RDF, RDFS come in. They add that structure and meaning to the mix.
Okay, I'm intrigued. Tell me more.
So OWL stands for Web Ontology Language, and it's all about defining concepts and relationships, but in this really precise and logical way.
Like creating a detailed roadmap of knowledge where everything has its place and you can see how everything connects.
Exactly. And that's so important for LLMs because it helps them understand the context and make connections they wouldn't be able to make on their own.
So instead of just bombarding an LLM with a ton of random words, we give it this neatly organized map that says, hey, this word means this specific thing, and it relates to the other words in these specific ways.
Yeah. It's like the difference between having a random pile of ingredients and having a recipe that tells you exactly what to do with them.
Makes sense. So what about RDF and RDFS then? How do they fit into all of this?
They're great for something called structured data representation. So it's all about organizing information in a way that's super easy for machines to digest.
Okay.
Like, say you're an LLM and you're trying to understand the relationship between Alice and Bob who work in the same company.
Right back to our company chart example. I'm starting to see the connection here.
Exactly. RDF uses this simple structure called a triple: subject, predicate, object. So in this case, it would be Alice works with Bob. It's straightforward and perfect for machines to process.
It's like giving the LLM these little bite-sized pieces of information that it can easily use to build up its knowledge.
Precisely. So we've got OWL providing that structured meaning, and RDF giving us this organized data, how do they actually team up to make LLMs smarter and more powerful?
Yeah, that's the big question.
Well, think about something called knowledge graphs. Imagine a giant web of interconnected concepts and entities, kind of like a mind map, but on a massive scale.
Okay, I'm picturing it.
OWL can define the structure and meaning of these graphs, making them incredibly rich and detailed.
Oh, wow. So now I'm imagining an LLM that can not only access this massive knowledge graph, but also understand the relationships between all these concepts. That's like giving it access to a whole universe of knowledge.
You got it.
Okay.
And that's where RDFS comes in again, because its structure aligns perfectly with knowledge graphs. LLMs can use this structured data to answer questions, generate text, and even make predictions based on the relationships within the graph.
That's incredible. It's like giving LLMs a superpower, the ability to use this vast network of knowledge to do some really amazing things.
Exactly. It takes them beyond just mimicking human language to actually understanding and reasoning about information in a much deeper way.
Wow, this is pretty mind-blowing stuff.
Yeah.
Now, I remember the source hinting at a future where OWL, RDF, and LLMs are all working together. What could that actually look like?
Imagine a world where OWL provides the structured meaning and reasoning, RDF allows for efficient storage and retrieval of knowledge, and LLMs act as these powerful language processors that tie everything together.
Okay, I'm getting chills. This sounds like we're talking about a major AI breakthrough here.
It really could be.
But what would this look like in real life? How would this actually play out?
Let's take healthcare as an example. Imagine a medical AI system that uses OWL to create a super detailed ontology of all those medical concepts, diseases, symptoms, treatments, the whole shebang.
So we have this incredibly rich and structured medical knowledge base thanks to OWL. Then what?
Then we bring in RDF to store massive amounts of patient data, medical research, and other relevant info. And finally, we have our LLM, which can access all this info, understand the relationships between different concepts, and maybe even reason about complex medical scenarios.
It's like having an AI doctor that can analyze your symptoms, understand your medical history, and come up with a personalized treatment plan for you.
Exactly. You're getting it. And that's just one example. This kind of AI could totally revolutionize fields like scientific research, education, even financial modeling.
Wow. I see why our source was so excited about the potential here. It's mind-blowing, to be honest. But are there any potential downsides to giving AI access to so much structured knowledge? Could there be any ethical concerns that come into play here?
That's a really important question to ask as we delve deeper into this world of AI and ontologies. It really is a crucial question. It's like we're giving AI this ability to not just process information, but to truly understand it, almost like we do.
It's exciting, but also a bit like, whoa, where is this all going?
I know, right? And you're spot on about those ethical implications. Like any powerful tool, there's always the potential for misuse.
Right.
One big concern is bias. If the ontologies we build or the data we feed these systems have biases built in.
The AI is just going to spit those biases right back out.
Exactly. So it's not just about the tech itself, but also about the humans behind it.
We need to be super careful about what we're teaching these AI systems.
For sure. And another challenge is transparency. As AI gets more and more complex, it can be hard to understand how it's reaching its conclusions.
That's a little scary, especially in fields like healthcare, where decisions can have really serious consequences.
Absolutely. We need to know how those decisions are being made.
It makes me think of those sci-fi movies where the AI takes over and turns against humanity. Okay, maybe that's a bit dramatic, but it does raise the question of control.
It's a valid question. How do we ensure these systems stay under human control? How do we make sure they're used for good?
Right, because the potential for harm is definitely there too.
Yeah, and that's something researchers and ethicists are really grappling with right now. One approach is to design AI systems that align with human values and goals from the get-go.
So bake in the ethics right from the start.
Exactly. And another is to create safeguards and oversight mechanisms. We need those checks and balances to ensure AI is used responsibly.
Makes sense. So lots to consider on the ethics front. But I'm also curious about the technical side of things. We've been talking about these huge knowledge graphs and how complex OWL and RDF can be. Is it even possible to build and manage all of this at scale?
That's another big hurdle for sure. Scalability is a huge challenge. Building these massive knowledge graphs requires some seriously powerful algorithms and computing power.
Yeah, I can imagine.
And then there's the issue of interoperability. All these different ontologies need to be able to talk to each other.
Oh, right. So it's not enough to just build these separate knowledge silos.
Nope. We need a common language so knowledge can be shared and integrated easily. It's kind of like trying to get everyone on Earth to speak the same language.
Yeah, good luck with that. But even with all these challenges, I have to say I'm really optimistic about the future of AI. It feels like we're on the verge of something truly incredible.
Me too. This convergence of ontologies, linked data, and these powerful LLMs, it's a game changer.
For real.
Personalized medicine, self-driving cars, even smarter search engines. The possibilities are mind-blowing.
It's both exciting and a little bit intimidating. But as we wrap up this deep dive into ontology, I think the biggest takeaway is that it's not just some abstract concept. It's a core building block for creating AI that can truly understand and reason about the world.
Exactly. And as you continue exploring the world of AI, remember it's not just about the tech, it's about the knowledge we build into these systems and the human values that guide their development.
That's a great point to end on. Well, everyone, that's a wrap for our deep dive into the fascinating world of ontology and its impact on the future of AI. We hope you learned a lot and maybe had your mind blown a little bit along the way.
Keep exploring, keep asking those tough questions, and keep pushing the boundaries of what's possible.
Until next time, happy diving.